Hello friends, welcome to thesitzer.com. Now in this video we will learn about the substitution reactions of alkanes. Alkanes, as we know, they are having a very less chemical reactivity, and because of this nature they are called as paraffins. However, from alkanes you can replace a hydrogen atom by a halogen. Suppose if you react an alkane with chlorine and you heat this reaction mixture, hydrogen can be replaced by the chlorine to get the alkyl halide and HCl. Now this reaction is a substitution reaction because we are replacing here the hydrogen by chlorine. So one atom being replaced by another atom. So this is a substitution reaction. Hydrogen here is being replaced as H free radical by the Cl free radical. So that means from chlorine molecule you get the Cl free radical, which replaces the hydrogen as H free radical from the alkane to get the alkyl halide. So this is a free radical substitution reaction. This is a substitution, but based on the mechanism, right, we see that this is a free radical substitution reaction because one free radical replaces another free radical. So this is a free radical substitution reaction. Free radical substitution reaction. And any free radical substitution reaction actually occurs in three main steps. Number one step is the insertion. Here we generate the free radical first, and then the second step is the attack of the same free radical on the alkane. That's called as the propagation step. And the third step is the termination of the reaction. That's called as the chain termination step. So now let's understand the mechanism of the free radical substitution reaction. Let's take an example of a chlorination of alkane, and from alkanes I'll take the simplest one, which is methane. If you react the methane with the chlorine, so what we get here when you heat it or we use the high energy radiations, hydrogen will be replaced by the chlorine, so you get the CH3Cl, methyl chloride plus HCl. So this is a free radical substitution reaction because from chlorine molecule you first get the chlorine free radical, and that free radical attacks on the CH4. So the first step in this reaction is insertion. So we have to generate the free radicals first. In a chlorine molecule, by heating or using the high energy radiations, the chlorine-chlorine bond breaks, and due to the homolytic bond fission you get the chlorine free radicals, right? So the bond fission here is homolytic bond fission. Okay, so this is a homolytic bond fission, a symmetric bond fission in which the chlorine-chlorine bond breaks and each chlorine takes one electron, right? And you get the chlorine free radical. In the second step, the same free radical will attack on the methane, on the CH4 molecule. That's called as the propagation step. Propagation occurs in two steps: propagation step number 1 and propagation step number 2. In the step 1, this free radical which was generated here in the insertion step, now the same free radical now attacks on the methane molecule, on the CH4 it attacks on the alkane, and it takes a hydrogen from the CH4 as H free radical, and so that means there is a homolytic bond fission in the carbon hydrogen bond, and that hydrogen reacts with the chlorine and forms HCl. Now you get the carbon with 3 hydrogen atoms and 1 electron. So this is a methyl free radical. This one is a methyl free radical, right? Methyl free radical. The same methyl free radical now in the step number 2 reacts with another chlorine molecule. it reacts with the chlorine molecule Cl2 molecule, and here again, due to the methyl free radical which attacks on the Cl2 molecule, it takes a chlorine, one chlorine here, due to the homolytic bond fission in Cl2 molecule. This chlorine reacts with the CH3 here and form with the CH3Cl. Plus you get a one chlorine free radical now. So in the two steps you can see that in the first step here, in the first propagation step, the chlorine free radical is used here, and the same free radical is generated in the second propagation step, so that all the methane molecules get converted into CH3Cl. The process continues. The same free radical now will attack on another molecule of CH4, again generates HCl and the methyl free radical, and again the process will continue. So from step number 1, we use the Cl free radical. In the second step, we generate the same free radical. Now the last step, which is called the termination step. Termination means when you don't get any more free radicals. A reaction in which you do not get any more free radicals. You can see here in the insertion step, in the first step here, or in the second step here, we get the free radicals from the product side. So in insertion or propagation, you see one of the free radicals there in the product side. A termination is a bit different. In a termination, you don't see any more free radicals from the product side. So any step where two free radicals can combine and form a neutral molecule without any new free radical generation, that's called as a termination step, right? So the third step is the termination step, and this can happen in different ways. Two chlorine molecules can combine, two chlorine free radicals can combine and form the Cl2. Chlorine and the methyl, they may form the CH3Cl. Two methyl, they may form the ethane. So in a termination, you may get more than one product. This is one of the drawbacks of the free radical substitution reaction. Now let us try to summarize the whole mechanism of this chlorination of alkanes. First step, insertion step. So this is the insertion step. You get the free radicals first. In the propagation step, you can see here the propagation step first, and this is the step number second. In the first step, we consume the free radical. In the second step of the propagation, the same free radical is regenerated, so that the process continues and we can convert the alkanes into alkyl halides. Okay, and the termination, you can see the two free radicals, different free radicals or the same free radicals, they may combine and form the different products. The net reaction you can get by adding the step number 1 of the free radical and the step number 2 of the free radical. If you add this one here, X free radical plus alkanes RH plus X2 plus R free radical, what do you get? You get the R free radical plus HX plus RX plus X free radical there. So we can cancel out these two. We can cancel out this one and this one also, and the net reaction will be alkane plus halogen molecule reacts and forms HX, halogen acid, and the alkyl halide. Insertion step is always used to start the reaction, and the termination step, here we end the reaction. The main products you get from the propagation steps. Hope you got the concept. Thanks for watching the video. Bye for now.